first term that we need to look at is what we call central tendency. There are three different calculations that fall under the category of central tendency: mean, median, and mode. You have assuredly calculated mean, median, and mode thousands of times in your academic career, so I know you're on the same page with me when you see these three words. I just want to clarify, though, that when you see a bullet and it asks about central tendency, these are the three possible answers, whether that's in multiple choice, which I know we will not see on this year's AP exam, or in the context of an FRQ. It's not impossible if they give you a short, small collection of data. Let's say I did a study and I showed a bunch of participants a scary movie and I calculated how many times they screamed while watching the movie. And I got the numbers 4, 4, 3, and 1. The average, which is what the mean means, we'd be adding these all up. This comes out to 12. 12 divided by the 4 participants comes out to 3. So in this case, our mean would be 3. The actual AP exam doesn't let you use a calculator. This being a take-home exam, theoretically you would have access to a calculator, at least I assume that would be the case. So it's not inconceivable they ask you about numbers that are a little bit more challenging and ones that you can't just readily do in your head. We'll see that when it comes in April or May, whenever the AP exam happens to be. Definitely not April, May, almost assuredly, but the date, again, is still being determined. The median is the middle point. When you have 4 numbers like this, it would eventually leave you in a scenario where you have 2 numbers. The median in this case would be 3.5. You can, in fact, have a median that's not actually one of the numbers. Had there been a 0 here at the bottom, and this would have been 5 numbers, the 3 would then be the median. The median is just the middle number, which in this case was 3.5, so we're going to eliminate the 0 down here. Mode is the most common or most frequent number in your set. Here the number 4 appears twice, so that would be our mode. It's the most frequent. This is a point that I'm going to bring up in a later video, but you might recall back in Unit 4, we talked quite a bit about distributions, skewed distributions to be specific. By skewed distribution, I meant when it looked like this, or when it looked like this, as opposed to the nice normal distribution when it's perfectly symmetrical. I'll bring this up again in a later video, but usually mean is the best central tendency when looking at a set of numbers. However, if there is an outlier, like maybe somebody in class cheated and got a 0, or maybe we're looking at family income and somebody in the class has an income level of $1 million, all of a sudden the mean can get distorted really, really quickly by outliers. So although the mean is usually the central tendency you check, median is the second best one. It tends to be the one you check under the circumstance of outliers. So you could conceivably see a question where it asks you that, where it has a skewed distribution, and it asks, now that the mean is sort of rendered useless, which central tendency is the second best? There are only 3 central tendencies. That scenario would give you median is the only appropriate answer. The second major topic that you encounter on FRQs that I think is worth talking about is how to recognize you're actually looking at a correlational research study as opposed to an experiment, as opposed to a case study or a naturalistic observation. I'm going to start here in the middle, move over here, and then towards the end of this section of the video, we'll talk about what I have under positive and negative correlation. One dead giveaway that you're looking at correlational research is that the results are shown in one of these 2 categories, either a table or a scatter plot. If you see a 2-column table like this, and this part's important, the table does not have a spot for mean, and the table does not have a spot for standard deviation. So you do not see mean and you do not see standard deviation. Just a collection of numbers like this in 2 columns, it's almost a guarantee that you're looking at correlational research. For example, let's say I did a study at Aponequid where I asked, how many hours a week do you work? And evaluate your stress level on a 1 to 10 self-report scale. And I have these results here. So one student said 4, and then 2, 6, and then 4, so on and so forth. The results are described in 2 columns. The mean is not determined, the standard deviation is not determined, nothing like that. Just simply 2 columns like you see here. This is a dead giveaway that you're looking at correlational research, because unlike an experiment, which is often what you might confuse correlation with, there isn't a control group and an experimental group. There's not an additional column that dictates one group or another. It's simply just 2 sets of variables and the numbers that you found when you conducted your research. This is a dead giveaway that you're looking at a correlational study. 2 columns, the names of 2 variables, no mean or standard deviation referenced. Alternatively, and this has been shown on the AP exam, it was like this I think 3 years ago, they showed a scatter plot and they asked, what is the conclusion that you can draw from this research? And because it was a scatter plot is a dead giveaway that you're looking at correlation. Scatter plot, in terms of a graph, is always shown with a scatter plot. Correlation is always shown with a scatter plot. Not a bar graph, no other type of graph, not a distribution curve, nothing. Always on a scatter plot. So if you see a scatter plot or a 2-column table, particularly one like this that has the names of variables at the top and it does not include mean, you're almost guaranteed looking at correlation. Now, from this point, the next type of question that you might often see is, what conclusion can be drawn from this type of data? Well, it might be hard to see in the video, but this scatter plot has a bunch of lines sort of in this upward slope like this. That is a good example of what we call positive correlation. The same is actually true with this table. As hours increase, stress level increases, indicating what we call a positive correlation, when both variables increase together. Now, it's not inconceivable that they give you an FRQ where the scatter plot is a negative correlation like so. In this circumstance, as one variable increases, the other variable decreases. That's what's happening here. Negative correlation is not down-down. That was a point that we made back in Unit 2. I know the word negative, you might assume we're talking about 2 variables that are decreasing together. But 2 variables that decrease together also increase together. So down-down is actually another example or another way of describing positive correlation. So if you see an FRQ bullet and it asks a question like, what does the data suggest, or what conclusions can you draw from this data? If it's a scatter plot, you have to use the word correlation. If it's 2 columns in a table like you see here, with the name of variables, it has to be correlation. From that point, make sure you appropriately address positive or negative correlation. The third point we're going to talk about is how to recognize that you're actually looking at an experiment as opposed to correlation or a naturalistic observation. The first dead giveaway is if random assignment is either described in the prompt, the researcher flipped a coin to determine which group participants went into, the researcher pulled names out of a hat, or the method that we like, the researcher used a random group generator to split the participants into 2 groups randomly. That's the dead giveaway. Either the process is described or the words random assignment are just used in the prompt, which is actually fairly common. The next way that you can definitively determine that you're actually looking at an experiment is if you see a table that looks something like this. This is an exact recreation of an FRQ from a few years ago. I actually showed you this question back when we talked about Unit 2, but it's not a bad idea to review it. The basic premise of the study, where this graph is pulled from, participants were either giving an article. The article either said that obesity is a result of a disease, so it's something that you don't really control, or obesity is the result of your own behavior, your own unhealthy eating. Then it asked each participant to evaluate the overall importance of healthy eating. What we found was that 3.4 as a mean for those that read the article that it's a disease, meaning it's kind of outside of your control, meaning the overall consensus, the overall feeling of that group was that healthy eating actually wasn't all that important, only a 3.4 out of 10. However, if you just read an article that told you that obesity was a result of your own behavior, the average out of a 10 was a 6.1, making it much higher and much greater importance for those who just read that article. This is a classic example of what a table looks like in an experiment, and there's a few different reasons. The first is you see the word group as a heading. Experiments intentionally produce 2 groups, sometimes more, but for the context of this study, there were only 2 groups. Correlational research does not do that. Correlation is 2 columns with the labels of 2 different variables. That's what a correlational table looks like. An experimental table, you will often see the word group, or you will often see what each group experienced. One group was intentionally randomly assigned to read an article about disease. Another group was randomly assigned to read an article about behavior. That clear difference between 2 groups is what makes this an experiment. Additionally, really only experiments will include the word mean, and only experiments will reference standard deviation. Those points are not really calculated in correlational research. It really doesn't have any value. Correlation is valuable because it shows you the actual correlation. the number between -1 and +1. Mean and standard deviation, we leave that for experiments. So if you see a table and it has either two groups like this, or mean reference, or really standard deviation reference, it's almost a guarantee that you're looking at an experiment. The other dead giveaway that you're looking at an experiment and not correlation, not a naturalistic observation, this one doesn't always work, but it usually works. I've never actually seen the College Board go in a direction where this wasn't the case, which is showing results in a bar graph. We could very easily take the results up here. I'll do it very quickly. Behavior group, disease group, and then on this side it was concern for healthy eating. We'll have this is 5 and this is 10. So if you thought it was a behavior, you went up to 6.1. If you thought it was disease, it was only 3. We can shade these in. Now we have a bar graph that takes the results of the study and visualizes it in a different manner. Correlation is not visualized in a bar graph. It's not impossible that you could visualize a naturalistic observation in a bar graph, like you did a week's worth of observations and you wanted to calculate how many times people went to a certain restaurant in the food court of the mall. Like, not impossible, but I've never actually seen that. It's a dead giveaway when you have a bar graph where there are clearly two different groups referenced on the x-axis. The same way that this table clearly has two groups, those two groups and means are clearly then indicated in the next column. The final topic in today's video is to reintroduce you to a term that we did in fact include on a concept map in Unit 2, but it's one of those terms that could very easily be glossed over. That term is variance. That's the term that we used in our concept map. I want you to be familiar also, though, with the term variability. They are, in fact, synonyms of one another. It's not inconceivable that you see an FRQ bullet. We haven't really asked it or prepared directly for this, where it asks you to describe how much the numbers in the sets involved in the study vary, or how much of a variability there happens to be. The word variance or variability, or even just the word vary, means you can use one of two different calculations to determine that. The term range and standard deviations are the only two examples of variance that we've talked about. So for example, if you were to see a bullet and it asks, describe the variance of the numbers, you could simply just calculate the range. That is a measurement of variance. Variance is simply just a term that we use to describe how much do the scores vary from one another. Well, if you were to see a question and it asks you that, you could very easily look at the numbers. Here I have the numbers 1, 3, 5, 7, and 10 under the category of disease, kind of thinking back to the third topic in today's video. To calculate the range, you would very easily take the highest number of a 10, subtract the lowest number, and get a range of 9. That is an accurate and precise way of determining variance. The range of the numbers in the set is 9. That is in fact true. You could calculate it for this one. This one, the difference is 8 and 5, so the range is only 3. Another way of describing variance, though, is to use standard deviation. This is a more challenging one to use, but it's not too bad. Standard deviation is a measurement. It's a single number that tells you how spread out the scores are, or approximately the number itself tells you how close or how far any score is from the mean. So for example, if you had a standard deviation of 10, that means on average any random score in the distribution or the set of numbers is 10 away from the mean. If you had a standard deviation of just the number 1, it would mean if you pulled out any random score in the set, it's only 1 point away from the mean. That difference there is an important understanding that you need to have in order to really grasp standard deviation. Because if you take a look here at these two sets, if you notice under disease, the numbers are very spread out. 1, 3, 5, 7, and 10. Without even knowing how to calculate standard deviation, which you do not need to know. The standard deviation in this set is going to be way, way higher than this one. Because if you take a look at this one, 5, 6, 6, 6, 8. These numbers are very close together. When numbers are very close together, as they are in this column, the standard deviation for that is going to be very, very low. So another way of approaching a bullet, if it were to ask you about variance, would be to simply look at the table like this. Very quickly see, okay, the numbers in the disease column are very spread out. The numbers in the behavior column are not spread out. You could very easily answer the bullet in 1 or 2 sentences and say, the standard deviation for the disease group is higher than the standard deviation for the behavior group. One sentence that does in fact describe how variance or variability, again a synonym of one another, are affecting or apply to the results in the study.